In the vast expanse of space where the stars twinkle like distant beacons and galaxies swirl in a cosmic dance, a lone traveler went silent. This traveler was not a human, but a machine, a testament to human ingenuity and curiosity. Voyager 1, humanity's most distant emissary, stopped responding. It was November 2023. This small spacecraft, launched in 1977, had journeyed farther than any other human-made object. For months, the signals from this intrepid explorer had been growing fainter. Each transmission was a whisper from the edge of the solar system, a faint echo of its once strong voice. Now, they had ceased altogether. The silence was deafening. Engineers and scientists at NASA's Jet Propulsion Laboratory strained to hear any sign of life from the spacecraft. Voyager 1 had been our guide to the cosmos for over 4 decades. It had ventured into the unknown, sending back invaluable data and images. It had sent back breathtaking images of Jupiter's Great Red Spot and Saturn's majestic rings. These images had captivated the world, showing us the beauty and complexity of our solar system. It had unveiled the icy beauty of Uranus and Neptune, planets that were once mere points of light in the night sky. Now, at the edge of our solar system, it had fallen silent. This silence was not just the absence of sound, but the end of an era of discovery. The silence was a stark reminder of the immense distances involved in space exploration. Voyager 1 was over 14 billion miles away, a distance so vast it defies comprehension. Voyager 1 was so far away that its signals took over 22 hours to reach Earth. Each message was a time capsule from the distant past, and now, those signals were gone. The control room, once filled with the hum of activity, was now eerily quiet. The world held its breath, hoping for a miracle. Scientists and space enthusiasts alike waited, their eyes turned to the stars, yearning for a sign that Voyager 1 was still out there, still journeying through the cosmos. The source of the silence was traced to a critical system failure. The engineers and scientists at the Mission Control Center were in a state of high alert, scrambling to diagnose the issue. Voyager 1's memory was failing. This wasn't just a minor glitch, it was a catastrophic failure that threatened the entire mission. This wasn't simply a matter of lost data. The corrupted memory meant that the spacecraft's ability to function autonomously was severely compromised. This was the heart of the spacecraft, responsible for routing communications and commands. Without it, Voyager 1 was like a ship without a captain, lost in the vast expanse of space. Without a functioning memory system, Voyager 1 was essentially adrift, unable to understand or respond to instructions from Earth. The situation was dire. The spacecraft was designed to be resilient, but this failure was beyond its capacity to self-correct. The memory issue meant that Voyager 1 could no longer properly process instructions. The team at Mission Control was working around the clock, trying to find a solution. It couldn't relay scientific data. The instruments on board were still collecting valuable information, but without a way to store and transmit it, the data was essentially lost. It couldn't even orient its antenna towards Earth for communication. The link between Voyager 1 and its home planet was severed, leaving the spacecraft isolated. The mission, it seemed, was coming to an abrupt and premature end. The sense of loss was palpable in the mission control room. The team at NASA's Jet Propulsion Laboratory was devastated. Years of hard work and dedication seemed to be unraveling before their eyes. They had poured their hearts and souls into this mission. Every member of the team had a personal stake in Voyager 1's success. They had nurtured Voyager 1 through its long journey. The spacecraft had traveled billions of miles, sending back invaluable data about our solar system and beyond. Now, they were faced with the prospect of losing it forever. The team was determined to find a way to save the mission, but the odds were stacked against them. The engineers at NASA refused to give up. They knew that Voyager 1 was still out there, hurtling through space, and they were determined to find a way to bring it back. They began to explore every possible option. Could they reset the system? Could they bypass the damaged memory? After weeks of brainstorming, a daring idea emerged. What if they could reprogram Voyager 1? The spacecraft had backup systems. What if they could reroute commands and data through those systems, bypassing the damaged memory entirely? It was a long shot. Voyager 1 was ancient in terms of technology. Its systems were rudimentary compared to modern spacecraft. Reprogramming it would be like performing brain surgery through a telescope, but it was the only hope. On April 18, 2024, the team at JPL began the most delicate operation in their careers. They would be sending a series of commands to Voyager 1. These commands, if successful, would reprogram the spacecraft. They would reroute its communication systems, bypassing the damaged memory. The risks were enormous. If they made even the slightest mistake, they could permanently disable Voyager 1. They could lose contact with it forever. But the team was undeterred. They knew the stakes. They knew the importance of their mission. The commands were beamed into space. They traveled for 22 long hours before reaching Voyager 1. Then, the agonizing wait began. Would the spacecraft respond, or would it remain silent? Then, a miracle happened. A faint signal was detected from Voyager 1. It was weak, but it was unmistakable. The reprogramming had worked. Voyager 1 was alive and communicating. The news of Voyager 1's resurrection sent shockwaves of joy and relief throughout the world. It was a testament to the ingenuity and perseverance of the human spirit. It was a reminder that even in the face of overwhelming odds, we can overcome any challenge. The team at JPL had achieved the impossible. They had brought Voyager 1 back from the brink, but their work was far from over. Now, they had to figure out what had caused the memory failure in the first place and how to prevent it from happening again. To truly appreciate the magnitude of this achievement, we must first understand the incredible journey of Voyager 1. Launched in 1977, Voyager 1 was on a mission to explore the outer planets of our solar system: Jupiter, Saturn, Uranus, and Neptune. Voyager 1 didn't disappoint. It sent back stunning images and groundbreaking data. It revealed the intricate details of Jupiter's atmosphere and discovered active volcanoes on its moon, Io. It unveiled the complex structure of Saturn's rings and found new moons orbiting the gas giant. Voyager 1's encounters with Uranus and Neptune were equally remarkable. It provided our first close-up glimpses of these icy giants, revealing their unique atmospheres and ring systems. It even discovered new moons orbiting these distant worlds. After completing its planetary tour, Voyager 1 continued outward. It crossed the Heliopause, the boundary between our solar system and interstellar space. It began sending back data from this unexplored region, providing us with our first direct measurements of the interstellar medium. Voyager 1's data revealed unexpected turbulence and variations in the interstellar medium. It also detected a mysterious humming sound, thought to be the sound of interstellar plasma vibrating. These discoveries hinted at the complex and dynamic nature of interstellar space. Voyager 1's journey has been a testament to the power of human ingenuity and the insatiable thirst for knowledge. It has shown us the beauty and wonder of our solar system and beyond, and it continues to inspire us to reach for the stars. The Voyager missions were more than just technological marvels. They represented the pinnacle of human ingenuity and curiosity, a testament to our desire to explore the unknown and push the boundaries of what is possible. They were the result of meticulous planning and a rare celestial alignment. Scientists and engineers worked tirelessly, poring over every detail to ensure the success of these groundbreaking missions. In the late 1970s, the outer planets of our solar system were in a rare alignment. This alignment, known as a grand tour, allowed a spacecraft to visit multiple planets in a single journey, something that had never been done before. This alignment, which happens only once every 176 years, provided a unique opportunity to send a spacecraft on a grand tour of the outer solar system. The planets were positioned in such a way that a spacecraft could use their gravitational pull to slingshot from one to the next, conserving fuel and time. NASA seized this opportunity and launched Voyager 1 and its twin, Voyager 2, in 1977. These spacecraft were equipped with cutting-edge technology and instruments designed to capture detailed images and data from the outer planets. The spacecraft were designed to take advantage of this planetary alignment, using a gravity assist technique to slingshot from one planet to the next. This technique, also known as a gravitational slingshot, allowed the Voyagers to gain speed and change direction without using additional fuel. This technique not only saved time but also fuel, allowing the Voyagers to travel farther and faster than any spacecraft before them. It was a brilliant use of the natural forces of our solar system, turning the planets themselves into allies in our quest for knowledge. This alignment was a cosmic gift, a rare opportunity to explore our solar system in a way that would not be possible for generations to come. The Voyager missions opened up new frontiers in space exploration, providing us with invaluable data and breathtaking images of the outer planets and their moons. They continue to inspire us to look to the stars and dream of what lies beyond. The Voyager missions have left an indelible mark on our understanding of the cosmos. They have expanded our horizons, ignited our imaginations, and inspired generations of scientists and explorers. The Voyagers are more than just spacecraft. They are our emissaries to the stars. Carrying golden records etched with greetings, music, and images from Earth, the Voyagers are messages in a bottle, cast into the cosmic ocean. They are a testament to our existence, our creativity, and our hope that one day we may not be alone in the universe. As we celebrate the miraculous comeback.
November 2023. A sense of unease settled over the Jet Propulsion Laboratory. Voyager 1, humanity's most distant emissary, had gone silent. The spacecraft continued to transmit, but the data made no sense. It was just a jumble of random binary code. The team held their breath. Something was very wrong. Launched in 1977, Voyager 1 was now billions of miles away. It was boldly going where no spacecraft had gone before, interstellar space, sending back data about the vast, unexplored region between the stars. The engineers at JPL sprang into action, working tirelessly to diagnose the problem. The solution would have to be ingenious, sent across billions of miles of space. It would have to breathe life back into a machine on the verge of being lost forever. The diagnosis was in. The problem lay in the flight data system, the spacecraft's brain. The culprit, a faulty memory chip. This tiny chip was responsible for assembling and transmitting scientific data back to Earth. With this chip malfunctioning, Voyager 1 was essentially speaking gibberish. The engineers faced a daunting task. The flight data system was a complex piece of 1970s technology. It was not designed to be repaired remotely. Furthermore, any command sent to Voyager 1 would take over 22 hours to reach it. That's 22 hours for the command to travel at the speed of light. Then another 22 hours to hear back if the command had worked. It was like trying to perform surgery on a patient with a 44-hour delay in response time. The team considered their options carefully. One option was to try and reset the faulty memory chip. However, this carried the risk of wiping out vital data. Another option was to bypass the faulty chip altogether. This would require rerouting data through other parts of the flight data system. This was a risky maneuver. It had never been attempted before, let alone on a 46-year-old spacecraft billions of miles away. The story of the Voyagers began long before their encounter with the edge of the solar system. It began with a rare celestial alignment. Every 175 years, the outer planets, Jupiter, Saturn, Uranus, and Neptune, align in a way that allows a spacecraft to swing from one to the next with minimal fuel. This gravitational dance, known as a Grand Tour alignment, was an opportunity too good to miss. In the 1970s, NASA seized this opportunity. They built two identical spacecraft, Voyager 1 and Voyager 2. These spacecraft were marvels of engineering. They were designed to withstand the harsh conditions of deep space. They were equipped with instruments to study the planets and their moons. They were also carrying something else, a message for any extraterrestrial civilizations that might encounter them. This message came in the form of the Voyager Golden Records. The Voyagers launched in the summer of 1977. Voyager 2 launched first, followed by Voyager 1 a few weeks later. They embarked on their grand tour, sending back stunning images and groundbreaking data. They revealed Jupiter's great red spot to be a massive storm larger than the Earth. They discovered active volcanoes on Jupiter's moon Io. They found evidence of a subsurface ocean on Jupiter's moon Europa. The Voyagers continued their journey, pushing further into the unknown. They reached Saturn, where they observed the planet's intricate ring system in unprecedented detail. They discovered new moons and shepherd moons, small moons that helped to keep the rings in place. They studied Saturn's largest moon, Titan, and its thick, hazy atmosphere. Voyager 1 then took a sharp turn northward, heading out of the plane of the planets, its mission to get a closer look at Saturn's moon Titan. This maneuver meant that Voyager 1 would not visit Uranus or Neptune. However, it put the spacecraft on a trajectory to eventually leave our solar system. Voyager 2 continued on its grand tour, reaching Uranus in 1986 and Neptune in 1989. It sent back the first close-up images of these ice giants, revealing their strange tilted magnetic fields and their surprising dynamic atmospheres. Voyager 2 also discovered new moons and rings around both planets. With their planetary encounters complete, the Voyagers embarked on their most audacious mission yet, to explore the interstellar medium, the region between the stars. This is a region of space where the sun's influence wanes and the effects of interstellar gas and dust become apparent. Section 5. A legacy etched in space. The Voyager missions have profoundly impacted our understanding of the solar system. They revealed the diversity and beauty of our planetary neighbors, showing our solar system as dynamic and ever-changing. The Voyagers captured our imagination. They symbolize our quest to explore the cosmos, testaments to human ingenuity and our desire to push boundaries, inspiring generations of scientists, engineers, and dreamers. The Voyager's mission continues, sending back valuable data, helping us understand the interstellar medium. This data aids in learning about galaxy evolution. The Voyagers will operate for at least another decade, powered by radioisotope thermoelectric generators, converting plutonium decay heat into electricity. As plutonium decays, power output decreases. Eventually, the Voyagers will lose power, but they will continue to travel through space, silently carrying humanity's legacy for billions of years. Back in 2023, the fate of that legacy hung in the balance. The engineers at JPL decided to take the risk. They carefully crafted a series of commands. These commands were designed to bypass the faulty memory chip in Voyager 1's flight data system. They sent these commands across the vast gulf of space, their hearts pounding with every passing hour. Then on April 20th, 2024, a signal was received. It wasn't gibberish, it was Voyager 1, and it was talking clearly again. The team erupted in cheers. They had done it. They had pulled off one of the most daring and improbable feats of long-distance space repair in history. This was a testament to the ingenuity, dedication, and sheer brilliance of the Voyager team. It was a team that had been working on these spacecraft for almost half a century. They knew every quirk, every workaround. They treated Voyager 1 not just as a machine, but as an old friend that needed their help. The recovery of Voyager 1 was more than just a technical triumph. It was a symbol of hope, a beacon of resilience in a world often consumed by the immediate and the mundane. This was a reminder that humanity, at its best, was capable of achieving the extraordinary, even in the face of seemingly insurmountable odds. The Voyager Golden Records are more than just time capsules. They are messages in a bottle, cast out into the cosmic ocean. They are expressions of hope that somewhere, out there among the stars, there might be someone or something listening. These records carry a selection of sounds and images that are meant to represent the diversity of life and culture on Earth. There are greetings in 55 languages, music from around the world, and sounds of nature like thunder, wind, and waves. There are also images of people, animals, plants, and places carefully encoded as analog signals. The records are attached to the side of each Voyager spacecraft, along with a needle and instructions on how to play them. Whether any extraterrestrial civilization will ever find them, let alone decipher them, is a question lost to the vastness of space. But the act of sending them, of reaching out to the cosmos with a message of peace and curiosity, speaks volumes about who we are as a species. It is a testament to our enduring fascination with the universe, our desire to understand our place within it, and our hope that we are not alone. With the Voyager 1 back online, the flow of data from the interstellar medium resumed. This data, though sparse, is invaluable. It is providing us with our first glimpses of the space between the stars, a region that has long been shrouded in mystery. The instruments on Voyager 1 are measuring the density, temperature, and composition of the interstellar plasma, the soup of charged particles that permeates this region. They are also detecting cosmic rays, high-energy particles that originate from outside our solar system. This data is helping us to understand the boundary between our solar system and interstellar space, a region known as the Heliopause. It is a turbulent and dynamic region where the solar wind, the stream of charged particles constantly flowing from the Sun, collides with the interstellar wind, the flow of particles from other stars. The Voyagers are providing us with a front-row seat to this cosmic ballet, a dance of energy and matter on a scale that is hard to fathom. They are showing us that our solar system is not an isolated oasis in space, but rather a part of a much larger and interconnected cosmic web. The story of the Voyagers is a testament to the power of human curiosity, ingenuity, and resilience. It is a story that continues to unfold, even as these intrepid explorers venture farther and farther from home. Their journey has inspired generations of scientists, engineers, and dreamers, reminding us that there are no limits to what we can achieve when we set our minds to it. And it has filled us with a sense of wonder and awe at the vastness and mystery of the universe we inhabit. As we continue to explore our cosmic backyard and as we prepare to send humans further into space than ever before, the lessons learned from the Voyager missions will serve as invaluable guides. They will remind us to be bold in our aspirations, to persevere in the face of challenges, and to never stop asking questions about the universe and our place within it. The Voyager's story is a story of exploration, discovery, and the enduring human spirit. It is a story that belongs to all of us. It is a story that is still being written, and it is a story that reminds us that the great